Thank you very much. Thank you very much, Heinrich, and thank you to Prince Michael and Kurt for inviting me to talk to you this afternoon. You're all looking pretty good at the moment for staying awake, so thank you very much for making it this far. Continuing the theme of evidence and information, my talk is going to be about the environmental impact associated with the use of crop biotechnology around the world since it was first really commercialized on a broad scale in 1996. Essentially, most of this technology has been two types of trait: insect resistance, which gives plants essentially protection against some of their major pests, and they are primarily found in cotton and maize, and herbicide tolerance, which gives tolerance to a plant so that if you spray the crop with a weed killer, it doesn't kill the plant, it just kills the weed. So it gives you better weed control. And that technology has essentially been widely used around the world in soybeans, in maize, in cotton, and canola, or more commonly known in Europe as oilseed rape, but canola being spring oilseed rape. So that is the context of where the technology has been mainly used. Yes, it's available in one or two other crops, and there are some other traits such as virus-resistant papaya in Hawaii or drought-tolerant maize in the United States. Just to give you a little more background about myself, I'm an agricultural economist. I've been looking at the impact of new technology in agriculture now for over 30 years. I also have done a lot of work looking at the impact of regulation on innovation. And back in the late 1990s, I started looking at the impact of crop biotech. And over that 20-year period, I've now written a lot of papers in peer-reviewed journals on the impact of the technology. So I would like to think that the information I'm going to provide to you has some credibility because it's in reputable peer-reviewed journals. And since 2004, we started trying to quantify the economic and the environmental impact of this technology where it's used around the world, and to update it on an annual basis. And the information that I'm going to present to you is essentially from the last report, which came out in 2018. Now, first of all, before I discuss the environmental impacts, I just think it's important to look at some key global challenges that the context of biotech crops are grown in. We have an expanding world population. This morning, you saw a graph of the speed with which the human population has been doubling, and the forecast of 9 billion mouths to feed by 2050, probably before then. And the need to provide an adequate volume of nutritious food for the global population. At the same time, we've got climate change impacting on world agriculture around the world. So we need to increase food production in a way that protects the environment as much as possible. Now, I think it's important to also place context here that all forms of agriculture, be they be using biotech, conventional, organic, all forms are bad for the environment. The best environment. If you want the best environment, you don't want agriculture, you want high biodiversity in unimproved land, forests, unimproved grasslands around the world. So, recognizing that we nevertheless feed the world, when we talk about environmental sustainability, we mean minimizing the negative environmental impact of agriculture. You cannot eliminate it. It's about minimizing it. But it's also important to recognize another aspect of sustainability, and that is you cannot have environmental sustainability without economic sustainability. Farmers have got to be able to produce food in an environmentally sustainable way that gives them a reasonable living. Now, has crop biotech contributed to a more sustainable agriculture? The information in our latest report tries to answer or provide some answers to this question. For those of you who want to look at this information in more detail, there are 2 open access papers in the journal GM Crops and Food. There's the link to it. One is on the economic impacts, one is on the environmental impacts. There's also a fuller report available on our website that's 200 pages long. For those of you who have trouble sleeping at night, you can always consult it. Clearly, for peer review papers, you can't have 200-page articles, so those are a bit shorter, and a lot of the information that I am going to talk to you about now is in the paper that you have in your packs. There's lots of information there for those of you who like numbers and detail. And my presentation is going to be focusing on 2 main aspects: the environmental impacts associated with pesticide use changes with the technology and carbon emissions. So how is this work done? Well, we review and use the considerable impact literature that is now available after more than 20 years of widespread adoption. A lot of this is in peer-reviewed journals, and we draw. But you can appreciate that there is not an impact paper on every trait, in every crop, in every country. So we have to do some extrapolation, and we have to do some of our own analysis. We're reviewing pesticide usage information, the amount of pesticide applied to a crop, and making comparisons between what is typically used on a biotech or GM crop versus a conventional crop. But just looking at the amount of a pesticide applied to a crop is not really a very good indicator of its impact on the environment. So we also use another indicator called the Environmental Impact Quotient, or EIQ. That was developed at Cornell University in the 1990s as a way of comparing the environmental impact associated with pesticide use on different production systems, but I'll talk a bit about that a little more later on. And lastly, review of the peer-reviewed literature on carbon impacts, mainly associated with fuel use changes and soil carbon storage. Again, I'll talk a bit more detail about that later on. In a nutshell, this slide gives you a summary of the entire report. So if you don't want to read the 200 pages, there's the numbers. 21 years of using the technology around the world, and bear in mind, very little of that is in the European Union. The technology has delivered 671 million less kilograms of pesticide active ingredient on that cropping area. That's equivalent to over an 8% reduction in the amount of insecticide and herbicides used on that cropping area. But interestingly, in terms of the environmental impact quotient, it's a far bigger benefit to the environment of over 18% reduction in the associated environmental impact. On the carbon side, I give you the 2016 figures. The technology has contributed to reducing global emissions by 27.1 billion kilograms less CO2 released into the atmosphere. To give you context, that's equal to taking 16.7 million cars off the road for a year. In terms of production, the technology, through higher yields because of better weed control and better pest control, you've got 659 million tons more of maize, soybeans, cotton lint, and canola. And the farmers who've used the technology have increased their incomes by $186 billion of extra farm income. That very roughly equates to an average farm income benefit of over $100 per hectare. Now, taking a step on and looking at that extra production that's coming from better yields, from improved weed control and reduced pest damage, you can see the technology has delivered 213 million tons more soybeans, 405 million tons more corn, and similarly additional production figures for cotton of an extra 27 million tons of cotton lint and nearly another 12 million tons of canola. Now, if I then said to you, if you took this technology away and you wanted to produce that extra amount of production conventionally, what would that require? Well, if you take the 2016 extra production that Biotech delivered around the world, that's what you come to. The world would need to increase the area planted to conventional soybeans by 10.8 million hectares, 8.2 million hectares of extra of conventional maize. So a total of more than 22 million hectares of extra conventional agriculture would be required. To give you some context, that is roughly equal to 36% of the cropping area in Brazil. So it's quite a significant extra area. Now, if the technology has contributed to producing that extra production by effectively offsetting the need to put more pressure on conventional agricultural production, you are effectively getting a climate change or an environmental benefit, which is effectively a land-saving impact. The additional production is reducing the pressure on agriculture to bring new land into production. And as I said earlier, the new land is typically high biodiversity land. For example, tropical rainforests. And as I said earlier, as all forms of agriculture are fundamentally bad for the environment, the best way to protect or minimize negative environmental impact of agriculture at a global level is to minimize the need to bring new land into agriculture. Let's now move back to some of the other aspects on environmental impact and return to pesticide use. I briefly touched on this. We looked at essentially insecticide and herbicide use data where it's available around the world. In terms of the amount of active ingredient used, or AI, but the amount of active ingredient used on a crop can be misleading in terms of environmental impact because the weight or the volume of use does not necessarily reflect the toxicity of the product. So this is why we also use the indicator, the environmental impact quotient, that originated in Cornell University in the 1990s. Now, for those of you who want additional information about that, I would refer you to various appendices in the papers, but essentially that indicator integrates various environmental impacts of individual pesticides into a single value per hectare. So it allows you to make those comparisons between the pesticides used, say, on a conventional crop versus a biotech crop in region 1 or region 2, or United States versus Argentina or the European Union. It is therefore a consistent indicator that allows you to make those comparisons. It is a better measure than just looking at the amount of active ingredient used, but it's still a fairly crude measure of environmental impact. If you really wanted to do the best environmental impact, you would need a hell of a lot of site-specific data, and that type of information is simply not available. So this is a crude way of looking at it, but it's better than just looking at the amount of active ingredient used. As I said earlier, over that 21-year period, from 1996 to 2016, use of pesticides on the biotech crop area has fallen by 671 million kilograms. To give you context, that is equivalent to about the total annual pesticide active ingredient use on crops in the combined countries of China, India, Australia, and Vietnam. China is the biggest user of pesticides in the world, not surprisingly given the size of the country. The largest environmental gains have come from the use of insect-resistant cotton. For those of you who don't have great knowledge of cotton production, traditionally, cotton is a crop that can be savaged by bollworm-type pests. It can utterly destroy the crop. And traditionally, farmers will have sprayed it with insecticide, this crop, to try and control bollworm pests. And traditionally, conventional cotton crops would be treated 15, 20 times a season. And that is 10, 15, 20 times is what your cotton farmers who grow cotton in the EU, in Greece or in Spain, will be doing, because they do not use biotech cotton. So you can see that with biotech cotton, what has happened is farmers have gone from spraying 15 to 20 times to only spraying 3 or 4 times a season. The spraying that they're doing is to control the pests that biotech doesn't actually control. It doesn't control all the pests, it controls a number of them. So you've got, as a result of widespread use of insect-resistant cotton around the world, and it's grown now on 3/4 of the world's cotton area, a saving of 288 million kilograms of insecticide use, about a 30% cut. That is an interesting amount because that is very roughly equal to the amount of pesticide active ingredient that goes on crops in the European Union every year. So it's a pretty big amount given the intensity of production in the European Union. And in terms of the EIQ value, it's a 32% reduction in the EIQ value. This slide is just one of the tables I took out of the paper where you can see those figures on insect-resistant cotton, and you can see the factors on different types of the technology. HT is herbicide tolerant, IR insect resistance. And you can see the indications that you've got very large reductions in the amount of active ingredient used with herbicide tolerant maize. But the way you look at, you can see significant differences in the amount of active ingredient used, but not necessarily the same correlation in environmental impact. One of the crops that always comes up in debate and often raised by activists is herbicide-tolerant soybeans. Globally, over that 20-year period, there's been very little change in the amount of herbicide active ingredient used on soybeans. In the first 10 years, there was a big cut, and then it started to increase again, but I'll come on to that in a minute. But interestingly, despite that, it's still nevertheless been a significant improvement in the environmental impact associated with the herbicides used. Very simply, glyphosate is replaced using a number of selective herbicides, and glyphosate is more, despite the issues that Klaus was referring to earlier, glyphosate is far more environmentally benign than the products it was or is replacing. Let's move on to greenhouse gas emissions. How does or has biotech made contributions apart from the extra production and reducing the pressure to bring new land into agriculture? Well, there are two main ways. Firstly, if you spray less, and in many countries in North and South America, spraying is done by machine, you use less fuel. And also, in relation to no-tillage production, which again I'll talk about more in a minute, if you plough the land less, you use less fuels. Moving on to the second aspect about no-tillage agriculture and how the crop has facilitated this, I have to take you a step back and assume that most of you will not necessarily understand or have knowledge of this. Why should you if you are not in agriculture? Apart from the cows that we just saw and their emissions of greenhouse gas emissions, which are the largest form of greenhouse gas emissions from agriculture, ploughing is the single biggest source of carbon emissions from arable crop production. Because if you plough the land, you're releasing the stored carbon from decaying plant matter. So if you can move to a reduced or no-tillage system, you're helping to retain the soil carbon from the decaying matter. But ploughing has also been a useful contributor to weed control. So if you want to go into no-tillage agriculture, you've got to find a good way of getting weed control that doesn't use ploughing. And no-till agriculture has been around for 40, 50 years. But a lot of the problems with it has always been farmers might go into it but they don't stay in it very long because they can't get good weed control. So they end up going out of it. When this technology came along in the mid-90s, farmers had a cheap, easy to use, very effective product like glyphosate, and to a less extent glufosinate, that gave them good weed control so they could go into no-till production systems, but more importantly, stay in it. And by staying in it, that has helped them contribute to reducing greenhouse gas emissions. No-till also gives you other benefits like more water retention in the soil and much less soil erosion, an issue that was raised in questions this morning to somebody's point that no-till agriculture, in fact it was Henry's presentation, answer to a question, that by going into no-till you're getting less soil erosion. And then the technology has contributed to that aspect. In relation to those two aspects, in 2016, the reduced fuel use from less spraying and less ploughing was 2.9 billion kilograms less CO2 released into the atmosphere. But interestingly, the bigger element from carbon saving coming from more carbon storage in the soil, facilitated by the no-till. So over 27 billion kilograms less CO2 released into the atmosphere. To give you the context, the equivalent to taking nearly 17 million cars off the road for a year. Excuse my UK-centric indulgence. It's easy for me to get the information. That's equal to taking more than half the cars off the road in the United Kingdom for a year. So let's give you some context. So it is not insignificant amount of carbon savings. If you then try to compute the figure over the 21 years, less fuel use, 29 billion kilograms less CO2 from farmers using nearly 11 million litres less fuel, equivalent to taking 18 million cars off the road. What about the soil carbon? Well, if you totted that up over the area that's in no-till, 251 billion kilograms CO2, if all of that land in biotech production had retained itself in no-till for every one of those years. However, not all of that land will have stayed in continuous no-till all the time, because farmers sometimes decide, well, we're not going to stay in this crop because the relative economics of soybeans relative to maize, relative to wheat may change each year, and they may determine that they're not going to necessarily stay in no-till all the time. So the 251 billion kilogram savings is a maximum. The actual amount will be lower, but the lack of data means we can't be any more precise than that, which is why I generally major only on the latest year figure. Now, so far, I've given you a presentation. Isn't this wonderful technologies, only benefits, no problems? Have there been any negatives? Well, the one that most frequently comes up and that is raised relates to the herbicide-tolerant technology, and there has been over-reliance on using glyphosate for weed control by some farmers in North and South America, and that has contributed to the development of weeds becoming resistant to glyphosate. So farmers in the first 10 years of using herbicide crop technology, you can see reductions in the amount of herbicides used by the weight of active ingredient across these crops. They replaced using 5 or 6 selective herbicides with 1 or 2 treatments of glyphosate. But it was too easy and too good. A lot of farmers got lazy and went into bad practices of just using glyphosate, even though many of them had been told for many years that's bad agricultural practice, you need to rotate, use different products and not do that. So they've had to adapt and change their weed control programs in the last 15 years. So they're now using glyphosate with other products to better manage the development of weeds becoming resistant to glyphosate. But it is important to put this in context. Weed-resistant problems are not new. They existed ever since man invented the first weed killer or the first pesticide. And weed resistance issues apply just as bad for conventional crops, not just the glyphosate tolerant or the glufosinate tolerant crops. And if you track herbicide use on the biotech crops, it's gone up in the last 15 years. It has gone up on conventional equivalent crops as well, in some cases more. So whilst, yes, when activist organizations say herbicide usage has gone up massively in the United States with this technology, it has in the last 15 years. But if you make the comparison with what it would have done if we'd stayed with conventional technology, it would have gone up much more. And the environmental profile of the herbicides used in 2016 on the biotech crops is still better environmental profile than the equivalent conventional crop in almost all the countries where it's used. And the herbicide-tolerant crops, even though farmers are having to spend more on using more herbicides, is still more profitable than its conventional alternative. If it wasn't, why would farmers be using it? You've got over 90% of the American crops. All 4 of those crops use the technology. Over 90% of soybeans and maize in Brazil use the technology. The same in Argentina and Paraguay and Uruguay. Concluding comment. After 20 years of widespread use, there is now a considerable amount of consistent evidence in peer-reviewed journals on the impact of the technology. And what I've talked to you about adds to that. As I said, the papers are available, freely available, no charge, open access on the website there. And I would encourage you to read these papers and the references cited in them, and ultimately draw your own conclusions about the contribution of the technology towards global food production. Thank you very much for your attention.